Well, hello. I'm going to start this first lecture in our higher cognition unit by reading your mind. In order for me to do that, I need you to make some decisions. So I want you to write down one example, the first that comes to mind of each category on the slide here. Write down a type of bird. Write down a color. Draw a triangle. Write down a motor vehicle. Write a sentence. List a hero. List a heroic action. List a game. Write down a philosopher. And finish off with a writer. If you need more time to do this, absolutely pause the video and restart it once you're ready to keep going. Now I'll assume you're back and you're ready with a full list. Number one, a type of bird. Did you write down a robin or a sparrow? Maybe a type of eagle? For a color, you wrote red. No? You wrote blue. When you drew a triangle, your triangle is probably equilateral, possibly isosceles. I very much doubt that you drew an irregular triangle with three sides of all different lengths. Is your motor vehicle a car? Probably. I would bet that your sentence is some short declarative statement. The boy ran home is the kind of example of what I'm thinking of there. A hero. Did you write a comic book hero? Did you write Superman? Batman? Or did you write a firefighter, maybe? A heroic action. You probably wrote a single act. Odds are pretty decent, actually, that you wrote a single act by a man. So did you write about a rescue by a fireman, maybe? A game. Monopoly. Some kind of board game? Number 10? No, where are we at? Oh no, we're on 9. A philosopher. When I read minds, my counting gets a little mixed up. Did you write Socrates or Aristotle? For writer, let's try J.K. Rowling. Been in the news. Stephen King. Now, I probably didn't guess all those for you correctly. And in fact, my guesses might be the worst for the last two. But the reason I can do any of them, and I can do this a little better in person, is because of how we learn categories. And so that's the main thing I want to talk about today. We're going to talk about category-based learning as the development and honing of prototypes. So I'm going to talk about those moments. I'm going to talk about the definition of the term prototype and how we make them. For this, and hopefully all videos moving forward, I am going to implement an activity for you that you may not have seen in any of these videos yet, or you may have, depending on what year you're watching this. What I'd like you to do is start immediately quizzing yourself on the content of these videos as you're going through them. So the way you're going to do that is you will first off download a copy of the slides. If you don't have access through a learning management system, you can email me and I'm happy to send you them. In the slides, you will see some blank ones, and your goal is to write on those blank slides about what you're learning and thinking about as you go through them. So as you follow along with the video and flip through the slides alongside, read through them, use other resources as you go to try and understand the ideas discussed, and when you hit a blank one, pause the video and write what you think you just learned on the previous slide. Summarize the important ideas, create an example, write about how you might use that idea. And keep in mind, there's no right answers here. This is what you pulled out of the previous slide. You might have to sometimes get creative to figure out how to use the ideas in the previous slide. Try to generate your own example if I just generated an example. Basically, think about and express your thinking. And the more you do that, the more you'll learn about what you're trying to memorize and the more you'll remember, both short and long term. The key to this is that you try to not go back and look and refer to other sources. Learn all you can, get to the blank slide, and then quiz yourself. It's kind of a small, self-made quiz. You could write a question and try to answer it. You could just write your thoughts. You could generate examples, whatever you want to do. And just try to do it without looking back at first. Then once you've sort of made your way through it and written all you think you can about the previous slide, then go ahead and look back, double check. Try to rely on your memory before you do that. But when you do, correct anything that you've written wrong. Okay, let's dig into today's first question. How do we learn categories? Usually, we start learning categories as children. You'll usually see some exemplar out in the world, and your parents will probably name it for you. They'll say, hey, that's a dog. Oh, great, dog. Now I know what a dog is. You see another one, maybe something similar, not exactly the same, and they tell you again, dog. So you will go, okay, those are both dogs, so dog varies a little bit. And then maybe later on you see another example, and you go, dog, and your parents go, no, not dog. Okay, not dog, great. So I know the edges of the category now. I know that some things aren't dogs. Not everything is a dog. And then as time goes on, you see others, dog. You see sort of the boundary conditions of the category. You see some strange exemplars. You see some typical exemplars. All kinds of dogs. You learn about variations in dogs. To the point where eventually you start to learn the basic descriptors that are required, but not necessarily exhaustive, for something to be a dog. Basically, over time, you build a more accurate prototype for the category, whether the category is dog or basically any other visual percept, and many, many other mental categories in our lives. So a prototype defined by textbooks is typically something like a generic or best representative of all members of a category. So that's why I've used this kind of dog silhouette as our dog prototype. It's not prototype like the early test version of something, like when you hear about a prototype of a new robot. It's more like the way we use the word prototypical, like something is just typical. It's the classic member of a category. Your prototype for dog might be a golden retriever, or it might be a brown lab. It would depend on sort of the category as a whole for you. Think about this from another direction. What's your prototype for bird? If you don't know the name of a bird in particular, picture a bird right now. What's sort of the prototypical bird to you? It's probably not a penguin, right? You're not picturing a penguin. The shape you're outlining is penguin. You didn't think penguin. Penguin isn't the most generic or best representation of the category bird. Usually it's robin or sparrow, hence my guess on a couple slides ago. And in addition to that, we also know through lots and lots of work on in psychology on testing reaction times that you would, and most of us would, be just a tiny fraction of a second slower to categorize a penguin as a bird than we would be to categorize a robin as a bird. So that's how psychologists know which exemplars become prototypes. If you show somebody a long slideshow and some items are dogs and other items are not dogs, and their task is hit the letter D for all the dogs, you'll hit D a little faster when you see a really prototypical dog compared to when you see a less prototypical dog. So said slightly differently, you could consider prototype as the average of a category. Like imagine if you could get like the mathematical average of ear length and snout length and fur color and body circumference of all dogs in the world, and you'd come out with some kind of average, most average dog. This is how visual cognition works, certainly, how identification of percepts works out in the world, but it actually turns out to be the case for lots and lots of other categories of cognition. Category is maybe not a great word to say there, because what I'm talking about is the establishment of categories. Our minds attempt to create categories and then to categorize new exemplars as quickly and efficiently as possible. So that's what the mind's job is. It's to make things easier for us. If we had to constantly consider every single decision we might possibly make, or really carefully identify all the possible variations and variables inherent in anything we see or hear or experience in the world, it'd take us forever to do anything. It would take you an hour to make a cup of coffee. But because we can quickly categorize most of what we encounter, and we act in ways that are simplified and made efficient by our previously learned mental processes and our knowledge about the world around us and the context of what we know, we have these really wide and complex networks of items that enable us to act more efficiently. You make a cup of coffee in a couple minutes. A couple other interesting things about prototype research and our knowledge about prototypes. We tend to remember exemplars of a category as a little more average than they were. So if you met a dog that was really out there and strange, you might remember it as slightly more average than it actually was in person. We also know that new exemplars pull around the average, which makes good sense. If you take the average of three numbers, what the first two numbers are might give you a really different average before the third one is added. So let's say you're finding the average of 5, 7.5, and 10. If the two numbers I give you first are 5 and 10, your average is going to be 7.5, and adding 7.5 won't change that average at all. But if my first two numbers I give you are 7.5 and 10, your average is going to be somewhere up above 8, like 8.75, and then when you add 5, it's going to drop it back down to 7.5. Same is true in this prototype example. If the first dog you meet is a pug and the second dog you meet is a dachshund, your prototype for dog is going to be some crazy mix of those two animals. It's going to take some time for your prototype then to kind of recalibrate around more and more typical dogs as you see them throughout life. This prototype theory of categorization also makes a kind of sensible argument for how things might mathematically and technically be stored in the brain, because if you stored a memory of every single dog you ever met, you'd have a lot of data in there. You'd have a lot of images, you'd have a lot of specifics, you'd have to record a lot of information that varies quite a lot. But on the other hand, if you imagine you could just store dogs as how far they are from your prototype dog, all you've got then is maybe like a set of numbers. So something that could be condensed down to only a few bits of chemical or mechanical information. You just need to store difference in ear length from normal, difference in color from the prototype, difference in leg length from the prototype, and so on and so on. So I hope you enjoyed this quick little extra lesson on category learning and prototypes. This is in the middle, it's by itself so that it's a short digestible video, but also because it could kind of fit in with memory, it could kind of fit in with decision making, and it could kind of fit in with development. So it bridges the gap across all three of these topics. See you next time.